We are doing Chapter 3, Section 2, page 140 in your pre-calculus textbook, problem number 18. In this problem, we are given a table. The first number represents the weight in grams, and the second number represents the number of raisins in a box of raisins. All right, first part, A, says, does the relationship defined by the set of ordered pairs represent a function? Well, if we were to look at our values here, for it to be a function, remember the x values cannot give you a different y value. So 42.4 gives you 87 here, and down here 42.4 gives you 90. So for part A, this is not a function. So A, we would say not a function. Now, there's more than just the 42.4. In fact, 42.3 also repeats. If you look, 42.3 here gives you 87, and down here 42.3 gives you 82. So the same x gave two different y values, not a function. Part B says to draw a scatter diagram of the data, treating weight as independent variables and the number of raisins as the dependent. I've already got the data in a Scatterplot calculator. I'm going to hit submit data, and we'll just make this a little bigger. Move this over so we can see our scatter plot. Alright, we look at our scatter plot. We do have some data pretty well spread out, but part of it is somewhat linear. What we're going to do next is a linear regression. So here I click on linear regression. In class, we will go over how to do a linear regression on the calculators. Now, if we take a look, this line here represents the line of best fit for this data. Okay. And in our linear regression, they give us some information. We are given our sample size, how many points. We're given our mean for x, the mean value for y. This is our y-intercept. And we are also given our slope. Now, keep in mind, this is not the y-axis because the x value is at 42.3, so this has been moved over. So it really will cross the y-axis at negative 399.123, and that would be rounded. Our equation would be y equals, and let's round this to 3 decimal places. So let's take for part C here. Because part B is the scatter plot. Part C, we will say y equals, and let's round this to like 3 decimal places. So 11.4. Now 49, after the 9 is a 2, so it'll stay at 49 times x, and then y is minus 399.123. This also stays at the 3 because the digit after the 3 was a 1. Now, this is our equation of our line that represents an average of the data. For part E, we're told to express our relationship using function notation. All that means is we take the y and replace it with f of x. And so f of x equals 11.49x minus 399.123. All right, next we are going to use the linear model, and this is actually part F. This was part E. So let me change this from there to E. Part D was the line, part C is our equation, and part B is the scatter plot. Part F, we are told to use the linear model to predict the number of raisins in a box that weighs 42.5 grams. So that means we are going to enter a value into our calculator for x of 42.5. So we are going to say f of x equals 11.449 times 42.5 in place of x minus 399.123. So when we enter our value for x here, of 42.5, it's going to calculate y as 87. We round it to the nearest tenth since all the y values are rounded to the nearest tenth. So 87.5. So f of x, or y, equals 87.5. Now, this could be also listed as f of 42.5 because that's the number we put in place of x to get the value of 87.5. And the last item is part G. It says, interpret the slope of the line found in part C. Well, if we were to look at the slope, let me scroll this. Our slope is 11.449x. Well, this is a relationship of the weight in grams of a box of raisins to the number of raisins. So every 11, let's see, we will have 11.449 raisins for every gram. That would be our interpretation. So if we were to round this last part, we could say about 11.4 raisins per gram of weight. And there we have it.